Now on the periodic table, which is listed in the upper right-hand corner right there, those again are the elements, all right? And the elements are really cool. Now each of the little symbols on the periodic table stands for a longer name. So for example, number 1, that H there stands for hydrogen, and number 2, the HE stands for helium. So the symbols, there's always one, sometimes 2 letters. The first letter is always capitalized, and the second letter is always lowercase. So if you're a person that likes to write in all uppercase letters, start writing lowercase. Chemists will get really freaked out by that, and I will be the same, I'll be honest. So you must write it big H, little e for helium. You can't write big H, big E for helium. That's a big faux pas. But anyway, this guy named Berzelius was the first one to think about that, which is kind of cool. Right now, there are 118 elements, but since I've been teaching at Mount Hood, that number has changed. Initially, there was more like 104 elements, and then over time, they started to add more and more and more, and now they get to 118, which is pretty cool. I am very excited for the next several elements, because if they can get to element 121, it's going to actually change the shape of the periodic table. So you can see right now, number 118, OG, is around. When they get to number 121, which is pretty close, there's going to be some big changes in the chemistry world, but they haven't gotten it yet, so we'll talk about that later if it happens, and also talk about why I'm excited to get to 121. There's a few pre-biblical elements, so before about 2,000 years ago, they all had different symbols, at least some of them did, but there weren't very many known. So in the last 2,000 years, there's been a lot of changes when it comes to chemistry. Big surprise, but it's kind of cool to think about the ones what they used to use and the ones that we're using now. Originally, Mendeleev was the person that kind of thought about organizing the elements as a periodic table. Initially, what he did is he tried to organize them by the mass, how much the atom weighs, and if you will. And we'll talk more about that as we go through and stuff here a little bit. But that didn't work out too well. All right, Mendeleev's idea of putting them by mass didn't really work out very well. So what they did instead is they moved it then to what's called the atomic number. And we'll talk about what the atomic number means later, but the atomic number worked out really well. Now notice that this periodic table lists only elements up to 112, and the last element picture I showed you had a periodic table up to 118. Periodic tables are almost inevitably out of date, so just get ready for it. But anyway, it was really cool, and Mendeleev's idea to kind of organize them turned out to be super cool. Mendeleev was able to predict the existence of a couple elements there, gallium, germanium, scandium, and technetium, elements that at his time hadn't been found yet, and they were found later. So he was able to predict it, which is pretty cool. Now on the periodic table, there's a couple terms we need to talk about right away. In the upper right-hand corner, the blue elements, those are called nonmetals. And hydrogen, which is also a nonmetal, plus those ones on the upper right, are pretty important to chemists, and we'll talk about that. On the left-hand side, all the ones in kind of the off yellowish kind of color, those are metals. So most of the periodic table is made of metals on there. And then the green elements that are listed right there, those are called metalloids. And metalloids have a combination of metal properties and non-metal properties. We'll talk more about that as we go through the course. But just realize non-metals in the upper right, plus hydrogen, metals, basically all the rest of the elements are metals, going to be pretty important for some of the discussions we talk about. This is a periodic table. Anyway, kind of fun, stuff like that. But again, you've got that same problem. The elements are always being updated, so you're not going to have the same kind of thesis. There's a big piece now which should be complete because, again, the elements go to 118. So anyway, just let you know, maybe having a periodic table isn't the best idea unless you are really into chemistry like me, who drools over this picture every time I see it, but that's another story. So in addition to the metals on the left-hand side, the nonmetals on the upper right-hand side, and those metalloids kind of going down the middle there, it's also good to know what a group and a period is. Now, groups and periods are pretty cool. Periods on the periodic table go left to right. So in the upper video animation there, you can see the combination of the red lines. Those are the elements in the different periods. So the first period literally has just hydrogen and helium, not too much. And the second period would be lithium, Li through neon on the right, and E. And periods have their use for them, but they're not as important as the groups. And in the lower right-hand corner there, you can see the groups in the periodic table. They go up to down, if you will, top to bottom. Groups are pretty important. A lot of chemical reactivity is defined by what group the element it is in. And we're going to see that the reactivity of pieces in the same group are often similar to each other. So for example, in group 1A, you can see there's hydrogen, lithium, Na is sodium, K is potassium. We're going to see that lithium, sodium, and potassium all have a lot of chemical similarities to them. Hydrogen does too, but hydrogen's kind of a different thing because it's a nonmetal. So we'll talk more about this as we go through the course. A couple of group names, though, I would like you to know. Group 1A, those are called the alkali metals, and they're very important for lots of different processes. Sodium in sodium chloride is an alkali metal, as well as potassium, stuff like that. Now, right next door is group 2A. That's the alkaline earth metals, and those are also important. Magnesium, calcium, beryllium, stuff like that. Notice the similarities in the names, alkali and alkaline earth. And look, I'm just the messenger. I didn't make these names, okay? They sound very similar, but alkali is group 1A, and alkaline earth is group 2A. Halogens are on the far right-hand side, group 7A. Halogens are also very, very important. Fluorine, chlorine, bromine, iodine. We'll talk about those quite a bit as we go through the class. And then on the very far right, group 8A, those are called the noble gases. Helium, neon, argon, krypton, etc., etc. By the way, notice how the groups have a 1A, 2A, this kind of designation to them. There are different versions of the periodic table, but in this class, what I'm going to use is I'm going to use 1As and 2As on the far left, and on the far right then you can see there's 3A, 4A, 5A, all the way over to 8A. And in the middle, there are the B groups. All right. And there are different versions of the periodic table, but this is the version that we're going to use in this class. And I'll try to make translations if you're using one, but try to get a periodic table with that kind of designation on them. It's usually Roman numerals. So instead of a number 1A, it's Roman numeral 1A, etc. But just realize that's what we'll talk about. Now, the B groups in the middle, those are called transition metals. They're also very important. And in the lower parts there, those two rows, which are kind of by themselves, those are called the lanthanides and the actinides. They're also metals. They're kind of like transition metals, but they have their own kind of special things. We'll talk about all of this as we go through the class. So the properties of matter, very, very important. It's really nice to know if you have a metal, a non-metal, or a metalloid. Definitely important. Now, some of the elements sometimes have a non-metal, non-metalloid color, and you can see in the lower right-hand corner there's some white ones. Those white elements are usually brand new elements, so they honestly just don't know what's happening on them. They don't know if they're metals or non-metals or metalloids. Now, probably they're metals because they're kind of to the left of that metalloid line, which here is kind of pink, but they just don't know yet, so they're trying to be safe. A lot of times a periodic table will also tell you if you have a substance which is a solid, liquid, or gas. And if you look at the color of the symbol of the element, you can figure that out on this periodic table. So if you look at hydrogen up there, number 1, it has kind of a red H. That red in this one means it's a gas. Most of the elements on the periodic table have black letters. That's black means that it's a solid. So most substances at room temperature and pressure are solids. But if you look carefully, number 35, bromine, Br, and number 80, Hg, which is mercury, those are both blue. Those are two substances which are both liquid at room temperature and pressure. So it's kind of fun to see which ones there are. Again, most elements are black, so that means most elements are a solid. In the upper right-hand corner, as well as hydrogen, you have a few gases, definitely, and there's only 2 liquids. And again, that's at room temperature and pressure, and we'll talk about why that's important later. But that's the phase of the matter you're going to see normally, all right? And you can change phases, but the normal way, that's what you'd see.